Okay, everyone, I am back, and this is part two. I believe that I should be able to complete the next three questions all in one part because this question 8.11, it is actually a two-part question. It wants you to conduct both a one-tailed and two-tailed test, and there's something I'm going to point out and show you, and it'll actually make things a little shorter. When you do your work, you're still going to have to show all of your work and all that kind of stuff. But for the sake of time and not having a video that lasts another 40 minutes, I'm not gonna do all of the calculations for the two-tailed test, and I'll explain why when I get to it. Okay, so on that note, question 8.11, this basically, there we go. So this question is basically saying a survey shows that 10% of the population is victimized by property crime each year. A random sample of 527 older citizens, 65 years or more of age, shows a victimization rate of 14%. They want to know, are older people more likely to be victimized? Conduct both one and two-tailed tests. Well, if you didn't have the second part about the conducting one or two-tailed test, you would know just based on the question, are older people more likely to be victimized? This is going to be a one-tailed test. If we didn't have the part telling us, hey, conduct both one and two-tailed tests, we would know that just normally this would be one-tailed. So I made the decision to go ahead and do all of the steps for the one-tailed rather than for the two-tailed, because if this was on a test, I would want you to do the one-tailed if you didn't have that last little sentence there. Okay, so that's one aspect of it. And that also comes into play when it comes to the null hypothesis, but we'll get to that when we work through those steps. Now, looking at this problem, some of you are probably trying to figure out, oh, okay, well, where's the information? Maybe you're trying to go ahead and write out the mean and the sample standard deviation, but you notice it's not there. That's because this is a proportion problem, okay? And it's a little bit different than some of the ones that I think were examples in the book and whatnot. Some of those you actually needed to calculate the proportion. You needed to know like what was how it was a certain proportion of a sample. You needed to have that information. Well, rather than you calculating, them giving you a number, they're giving you the percent. They're giving you the information in terms of percentages, and those percentages are ultimately your proportions. Because remember, a percentage is basically a proportion that's been multiplied by 100. Okay, so we know that where it says a survey shows that 10% of the population is victimized by property crime, we know that that's really saying 0.10. That would be our proportion, and that's going to be our proportion for population. So that's our population proportion, because this is different from confidence intervals. If you remember correctly, with confidence intervals, you were given a formula basically, and that formula had a number that was already set. You use that number for every single confidence interval for a proportion. Well, that's not the case when it comes to hypothesis testing. You have proportions that are tied to that specific sample, question, problem, however you want to look at it. So in this case, our population proportion is going to be 0.10. All right, so let's go ahead. I'm going to go ahead and start writing some of the information out. So okay, and I'll come back to the population proportion in a moment. But moving on with the question, or the rest of the setup, it's talking about the population is victimized by property crime each year, a random sample of 527 older citizens. So I know my number. I forgot my highlighter was still on. I know my number is going to be 527. So N is equal to 527. Let's see. My sample proportion is going to be 0.14. And that's because where it says a random sample of 527 older citizens, 65 years or more of age, shows a victimization rate. I knew there was something I needed to be doing. Shows the victimization rates of 14%. Okay. 10% of the population, 14% of the sample of older citizens. That's our key information from this particular question. I'm going to actually scroll up, but I remember these numbers, so I'm going to go ahead and write them. But I need to scroll up so that I can see. Let's do this. All right, so our sample proportion is equal to 0.14, and our population proportion is equal to 0.10. Okay, now for some of you, you may be in a little bit when I get to the formula, you may not remember how to do what the formula is for a proportion. Well, all you need to do is go to pages 208 and 209, and it'll give you the formulas for the Z obtained for a proportion. All right, so let's go back up. We'll come back to this, but let's go back up here to our test. Now, remember previously I was talking about the key thing that you need to pay attention to when it comes to step one. The key thing is that levels of measurement. Okay, and if you notice the previous problems, we said the levels of measurement have been interval ratio. And that's because those numbers had numerical value. You know, when you have a salary, that's a numerical value. You can do things with that. Well, in this one, our level of measurement is actually nominal. Okay, we're looking at something that can't be, you can't do anything like numerical with it. This is actually looking at victimization, something that's happening to people. So this is something that's categorical. You know, this might be something that's a yes, no answer. You know, it could be a question on a survey asking a citizen if they've been victimized. Have they been the victim of property crime? And so they would answer yes or no. That's categorical. Okay. All right. So the level of measurement is nominal, and that's, you have to make sure you identify that. Don't get in this habit of, you know, you copy and paste this information and you forget to go back and change the information for this one. You need to keep in mind that when you're working with proportions, that information is going to be nominal. Okay. All right. So stating the null hypothesis. The key thing that changes here are these symbols. The key things that change here are these symbols. So instead of the population mean, you remember we had the M, the funny looking M as I call it. Well, that's no longer there. Instead, we have P subscript U, at least I think that's what that is. It's so small in the books that I can never tell what that is supposed to be, but it looks like a U when I look at it. And then the alternative or the research hypothesis is, population, or P sub S. Actually, my apologies, I have a typo there. That actually should be a U. That actually should be a U. So let me go ahead and fix that. And this is why why you check things. You know, most professors would probably be a little bit embarrassed and say, oh, I have a mistake on my PowerPoint, or I have a mistake in the problem. I'm kind of glad you guys get to see it, because actually, let me just do this, because it reiterates the points that I'm always making about checking your work. Okay, this is something that I thought I caught, and then I thought I would have checked and not missed, but that is not the case. There we go. Okay, so your null hypothesis, which is the first one, is that the population, population proportion is equal to 10. The alternative, the symbols for the alternative is that the population proportion is greater than 10. And here's why. Remember up here, it says, are older people more likely to be victimized? Okay, that's letting us know that we're dealing with the one-tailed test. Okay, for this particular part of the question. Plus, they tell us to conduct a one-tailed test, and I'm going ahead and doing it. But this information tells us the direction of the tail, of which way we're going. And because we're saying are older people more likely, we want to know if basically if the proportion for older people, is it higher than the proportion for everyone else? Okay, so that's how we know that we're going to use the greater than sign here. Now, the next step 3, selecting the distribution. Now, you can kind of cheat on this when it comes to proportions. We're never going to have a proportion, at least for chapter 8. We'll never have a proportion, a hypothesis test with a proportion as we work on stuff in chapter 8, where it's a small sample. The proportions are going to always be large, are considered large. Those samples are going to always be considered large. So 100 or more. So you know that automatically it's going to be a Z distribution. Okay, you know that automatically. All right, so now we are at the part to compute the test statistic, excuse me. And then remember, I said the formula for this is on pages 208. It's formula 8.3. Yeah, it's on page 208, formula 8.3. And then it shows up again on page 209 in your course textbook, where they are giving an example where they go through and they do the problem. But I'm going to go ahead and write everything down as per usual. All right, so the formula for this is the okay, I keep doing that. Oh, I missed it. Okay, it's not clicking. Okay, let's try this again. Okay. All right, let me see. I'm not sure what's going on. Let me see if I can get this figured out. Okay, I got it. My apologies for that delay, but I got it. I figured it out. I don't know what was going on with the eraser, but anyway, so let's go ahead and write this, write out this equation. That's going to be the sample proportion, so which is symbolized with the P sub S, subtract the population proportion, which is symbolized with the P sub U, divide that by your, and all of this is going to be underneath the square root, signifying that once you're done with the calculation in here, you get the square root, and that's going to be population proportion, okay? 1 minus the population proportion again. So that number that comes out of this multiplied by the population proportion, and all of that then gets divided by N. Okay, so, and this is Z critical, okay? I mean, not Z critical. That is going to be Z obtained. And I just realized, I think I skipped the whole step. I'm so used to doing this that I skip steps. This should be pretty much straightforward. So I'm backing up, I'm coming up to step 3 because I skipped right on over it. This should be pretty straightforward at this point. We know for this particular problem, we're doing a one-tailed t-test, alpha level 0.05, and we know that a one-tailed test, excuse me, not test, but a alpha level of 0.05 comes out to a z-score of 1.65. And because we are looking for greater than, we're looking for our number to be higher. So more likely, greater than, higher than, that's going to always be positive. We don't need the negative sign. If we said less likely or less or lower, then we'd have a negative sign. So this information here, hopefully that's pretty straightforward. All right, so back to what we were doing, what I was doing. All right, so now it's time to plug in these numbers. So the population proportion, excuse me, the sample proportion is 0. Actually, I want to move this up a little bit because I'm going to need all the space I can get for this one. Okay, so the sample proportion is 0.14. Subtract the population proportion, which is 0.10. That's going to be divided by, we're going to do all of this underneath that. Okay, so that population proportion again is 0.10. It's going to be multiplied by 1 minus the population proportion, so 0.10. And then all of that gets divided by 527, which is the number. All right, so let's go ahead and do some of the calculations here. And to save on time, and also because I don't want to keep writing this out, I'm going to go ahead and do the calculation for this. So let's go ahead and get the calculator back out. All right, so 0.14 subtract 0.10 is equal to 0.04. So go ahead and write that here. Divide that by this information. So we're going to go ahead and do this calculation right here. Okay, so let me do this in red. I'm going to go ahead and do this calculation in this step. All right, so this is going to be this number in parentheses 1 minus, and remember it's the population proportion that was given to us in the problem. So 0.10, that gives us 0.9. So when we come back over here, okay, yeah. When we come back over here, we get 0.10. That's going to be multiplied by 0.90. All of that gets divided by 527. Okay, I got to scroll down. Okay, so next step. Z is equal to 0.04 divided by. So let's get the calculator out again. So I just did this calculation, but I always tell you guys, clear everything out just to make sure you don't have something left over. I could have just multiplied it by 0.10, but good practices. I have to mimic and do good practices. So 0.10 multiplied by 0.90 is going to give us 0.09. So then we have 0.09 divided by 527. That's going to give us, let's see here, I'll go right here, Z equals 0.04, which is then going to be divided by the square root of this outcome, which is 0.09 divided by 527. That gives us, and remember, I keep going all the way out to the fourth digit. So it's going to be 1.7077. The number right after that 7 is another 7. So that's going to turn that into an 8. So my number is going to be 1.7078. So 1.7078, that's the number that I want to get. Yeah, I had a feeling this was going to be one of the ones. I might have to actually go up a little bit. Let's see if I can get it in there though. Okay, so Z is equal to 0.04 divided by this number, whatever that square root is. Okay, clear it out. So 1.7078, we get the square root. That's going to be 1.3068. Because remember, I'm going out to the fourth number. And the number after that 8, which is my fourth one, is a 2. So I don't need to round up. So 1.3068. Okay, 1.3068. And I'm just going to do this. I'm just going to go horizontal at this point. So that means my Z is going to be equal to, let's do that math, clear it out, 0.04 divided by 1.3068. That gives us 0.0306. Okay, 0306. Yes. Okay, so 0.0306. Now here's the thing about this one. This one is a little bit different. This one's a little bit different. Actually, let me erase this because I want to come down with this. So let me do this real quick. Okay, so the answer for this is going to be up here. Because remember, I said Z is going to be equal to 0.0306. Remember, this question started off as a percentage and we turned it into a proportion. So what we end up needing to do is turn it back into a percentage. So how do we do that? We take this number, I'm going to clear it out, 0.0306 multiplied by 100. That gives us 3.06. So if any of you have already worked this problem in the back of the book and you saw the answer back there and you're like, how did they get that number? This is how. Once you do the calculation for the proportion, you turn it back into a percentage. But at the end of the day, it's a Z score. But to get it back to the original, like the way the numbers were, you'd multiply by 100. It's weird the way it works out like that. Most of these problems with the percentages, they don't always do that. But this one, the people who came up with this question in the book did that. So I just wanted to make sure you saw that in case you're one of my folks who's already done some of the questions at the back of the book. So then our Z becomes 3.06. Okay. All right. Now, what was our Z obtained or Z critical? It is 1.65. So now we're going to come down here, step 5, and our Z critical is equal to 1.65. And remember, we don't need to do plus or minus on this one because it's one direction, okay? Z obtained. Okay, so the Z obtained is going to be that's equal to that 3.06 number, okay? All right, so because it's one direction and we know we want everything to be higher, we come over to the right side of the table. We come over here where the numbers are positive, because remember, these are essentially Z scores. All right, so 1.65, it's not quite how I wanted that to look. Let's try that again. All right, so 1.65 is a little more than half. So 1.65. And then we know that the Z obtained is out here at about 3.06. So we'll just say that's 3.06. And remember what I said about the critical region? The critical region is everything beyond that Z critical. So all of this, which means your the Z obtained of 3.06 falls in the critical region, we reject the null. And here's the statement right here. With a Z critical of 1.65 and a Z obtained score of 3.06, the null hypothesis is rejected. The difference between the older citizens and the rest of the population's victimization is statistically significant and in the predicted direction. Older citizens are more likely to be victimized, okay? Simple statement. You've given the information that needs to be given. You've indicated that that they are more likely to be victimized, so on and so forth. Now, this is the question that I was telling you about. All of these calculations right here, we literally could take those and put them down here for step 4, okay? So what I'm going to do is just go through the key parts, because this two-tailed test, the main thing that's going to change is your Z critical, okay? We already know, because it's a proportion, it has to have a large sample or sampling distribution, it has to be large. or yeah, the sample size has to be large, which means there's a certain calculation you're going to use, but it also means that you end up using the Z distribution, okay? So that's just automatic, we know that. In this one, oh, also it's still nominal. The information, wrong thing. The information is still considered nominal, okay? Instead of, remember in the other one, it was, oh, and I did it right here too. I was consistent with my mistake. If you notice that I have the PS and it should be PU, P subscript U. So let me do this because that's going to bother me. I want to make sure you can see what it's supposed to be. There we go. Okay, so as you can see, the null hypothesis is the same. The null hypothesis is basically the population proportion is equal. There are no differences between the two proportions, between the population and the sample proportion. Whereas the alternative hypothesis, the research hypothesis, is saying, yeah, there's a difference. They are not the same. That's what this right here means. Now, here comes the part that's key, that makes a big difference with this particular question. Now for you, let's say you get something where it tells you to do a 1 and 2 tailed test. You need to go ahead and just write the stuff out. Yes, it's tedious, but you still need to write it out. And I can guarantee you, you do have a question on the assignment where you're required to do a 1 and 2 tailed test for a problem with the same information, okay? But the key difference here is for the 2-tailed, rather than 1.65, I have 1.196, and it's plus or minus 1.96, okay? Now that computation for the test statistic is gonna be the same as the problem above, and you're gonna ultimately end up with Z is equal to 3.06, okay? So same thing here. Everything, because all of the information is exactly the same. You're still doing the same calculation, It's just that instead of a Z critical of 1.65, your Z critical is now, okay, is now 1 plus or minus 1.96. Z obtained is actually still the same. That's going to equal 3.06. And remember, since it's on both sides, when we do the Z critical, you got to do, like if you plot this out, do it here as well as here. So you do it on both sides of the curve of the distribution, 1.96. And remember, our number is way out here, okay? It's 3.06. And the critical region, because everything is split up on two sides, this is a two-sided, a two-tailed test. You're looking for anything that falls over here and anything that falls on this side. So if the number had been negative 3.06, it still would have, you still would reject the null. Okay, and so with that, with the Z critical of plus or minus, and I'm reading the information now, okay? So with the Z critical of plus or minus 1.96 and a Z obtained score of 3.06, the null hypothesis is rejected. The difference between the older citizens and the rest of the population's victimization is statistically significant. The difference is so large that we may conclude it did not occur by random chance. The decision to reject the null hypothesis has a 0.05 probability of being wrong, okay? So that's essentially that. That's the difference between that problem where it was one-tailed versus two-tailed. And sometimes that can come into play because let's say that the number was, let's say instead of 3.06, let's say the Z obtained had been, oh, I don't know, let's say it had been 1.88. Okay, let's just say it had been 1.88. Oh. Okay, let's try this again. Let's say the Z obtained had been 1.88. We're gonna do this out here, 1.88. Let's say that that's what it had been. For a two-tailed test, it wouldn't have been significant. We would have rejected the null. But, I mean, we would have failed to have rejected the null. So we would have basically said our alternative hypothesis is not true. There are no differences. We would have failed to reject the null. However, in a one-tailed test, that same 1.88 would have been, we still would have rejected the null. So whether it's a one-tailed test or a two-tailed test, that makes a difference, okay? That really does make a difference, folks. So you'll want to make sure that you get that information correct so that you don't end up with the incorrect interpretation. All right, so this is actually the last, this is going to be the last example. Uh-oh. There we go. Okay, so this is going to be our last example. All right, so let's get the highlighter out. Okay, so the city manager has received a complaint from a local union of firefighters to the effect that they are underpaid. Not having much time, the city manager gathers the records of a random sample of 27 firefighters. So there's our information about our sample. So we know we have a sample of 27 firefighters. Okay, and the city manager finds that their average salary, so that's our, so we've got a number, so we're dealing with interval ratio. So here we go. We've got interval ratio. So that's our sample mean, okay, with a standard deviation of $575. But what this lets us know is that standard deviation, that is for our sample. So in all likelihood, we probably don't have a population standard deviation. So I'm gonna go ahead and cross that out. We don't know that. So we're left with two options. All right. And okay, so our average salary, average national salary, so this is a salary for, across the nation, is $38,202. How can she respond to the complaint? Should she use a one-tailed or two-tailed test in this situation? Why? What would she say in a memo to the union that would respond to the complaint? So a question like this, not only do I want you to give the interpretation, the stuff that I've been typing up at the end, but you would also answer these questions. So, okay, so yeah, you would answer these questions. So let's go ahead and go back to figuring out which distribution we need to use. Now, remember I said it's a sample of 27. That's a small sample, okay? So we come over here and we see the sample is large. Nope, it's not, it's small. So we know we're not using this and we're not using the Z distribution. So we've got to use a T distribution. Okay, so we know that T is what we're looking for. Now, let's go ahead before we come over here and get the T distribution and get that number. Let's talk about some of the information in here real quick. So let's see, I think I want to go to, I'll do this blue. All right, so first question, how can she respond to the complaint? Well, that's what these questions help answer. So the first question, should she use a one-tailed or two-tailed test? Now, I hope maybe you've tried to answer that on your own, which would be awesome. That would be great if you did. But if you didn't, she's going to use, I would suggest she use a one-tailed test. And the reason why is because the local union of firefighters, okay, so the local union of firefighters are saying that they're underpaid. Underpaid means you're not getting paid enough. You're getting paid less than everyone else. Okay, so she's got to find out, the city manager has to find out, are the local firefighters getting paid less than the national average of firefighters? So she's comparing these two different salaries, and she's basically, the hypothesis is that the local firefighters get paid less. So you use the less than sign, okay? So that's our research hypothesis, our alternative hypothesis. So that answers that question. And I just kind of I gave you the reason why. All of this, when I highlighted that and I was talking about, the union of firefighters gets paid, they say they're getting paid less. You know, that's why you would do a one-tail test, and the direction. So you would answer that information, you type it up, give me a sentence or two, and explain that. Okay. What would she say in a memo to the union that would respond to the complaint? Well, that's basically, you know, towards the end. You take the information that you learn, and when you give the interpretation that I have at the end, you basically take that and you would turn it into normal speak. Okay. Which I'll do at the very end. All right, so let's go ahead and get to, let's start working through the steps. And what I'm going to do, no, I'll leave it. I'm not going to move anything. Okay, so let's go ahead and work through the steps. So step one, we've already determined that this is interval ratio data. So you'd go ahead and you write out this information. I've already talked a little bit about the hypothesis. So you know, for a null hypothesis, the formula, or not formula, but the symbols are always the same. It's just the information you plug in that's different. It's always going to be that the population mean is equal to, or, you know, whatever it is that you're looking for. Those two items, those two groups, they're similar. They're the same. There's no real difference. Whereas your alternative, this is where you either say not equal to, where it's this little symbol right here, where it's the equal sign with the equal sign with the bar. Okay, that's a little bit better. But basically saying not equal to. Okay, so if it's a two-tailed test, that's the symbol you use. If it's a one-tailed test, you either use a greater than or less than sign, and you use the greater than if you're looking for something where you're saying that the sample is higher than the other group, or whatever, however you're putting it. You use less than when you're saying that, the less than sign when you say like someone's underpaid, they fear something less or whatever. Okay. All right, so now we're at the part for our t-distribution, our sampling distribution. We've already determined that we're using the t-distribution, and I've already said it's going to be at the 0.05 level. Okay, so now what we need to do is come get this number. So let me show you this number again. Let me show you the steps to getting it. Okay, so first I need to zoom in. Uh-oh, I might have zoomed in too much. Okay, no, that's enough. Okay, so you so you zoom in, and remember that our sample in this one it's 27 firefighters, if I remember correctly. Yes, a sample of 27 firefighters, right? So we have 27 firefighters, and remember, to get degrees of freedom, you do the number, subtract 1. 27 minus 1 is going to be 26. All right, so I know that this is where I need to look. I need to look at the row that's 426. So let's go ahead and highlight that row. Okay, there we go. All right, and so now I come up to the top of the table, and I said that I am doing a one-tailed test. So I look at this top level. Remember the last time I looked at this one, I looked at two-tailed test, but we're doing a one-tailed test now. And it's one-tailed at the 0.05 level, okay? So what I'm gonna go ahead and do is just highlight until I get here. Now, really and truly, I could have just come down and I would have found it, but I like for you to be able to actually see everything play out. And so that gives us this 1.706, okay? Don't round the number up. Use the full 3 numbers. Use all 3 numbers. Do not round it up. All right, so let's go ahead and zoom back out. And we'll come over here and start working on our calculations. For this one, I haven't written any of my information in yet. So let me go ahead and do that. I have my pen going. All right, so let's see, what do I know? I know that my number for my sample is 27. So I'm gonna go ahead and write down the n equals 27. Let's see, my average salary for my sample, where are they? Okay, not having much time, city manager, okay. Sample of 27 firefighters, she finds that their average salary is $38,073. So my sample, which is We use the X bar symbol, it's $38,073. My population mean, or my population mean, or that average salary for the nation is, if I remember correctly, $38,202. But let me go and check. Oh, well, it's actually right here. $38,202. And the standard deviation. My standard deviation is $575. So let's go ahead and write the sample standard deviation is equal to $575. Okay, so let's go ahead and work on that calculation. This is where I'm going to go through and plug in the appropriate numbers. All right. Oh, actually, I take that back. This is where I'm going to go through and put in the formula that goes along with the T obtained. And if you need to find the formula, you can find it on page 206 of your course textbook, okay? All right, so that's the formula that I am using. And let's see here, because it's a small sample, it's gonna be, yeah, n minus 1. All right, so the formula. So we would say sample mean subtract the population mean, which is gonna be equal to, sample mean subtract the population mean divided by the sample standard deviation, which is divided by n minus 1. So that's that formula. All right, so let's see how much space. Oh, I gave myself plenty of space for this one. All right, so let's go ahead and write this out. All right, so Z obtained is going to be, sample mean here is $38,073. Oops. Okay, let's try that again. So $38,073. Subtract $38,202. That's going to give us, oh, well, I forgot, we got to do this. So our sample standard deviation is 575. That's going to be divided by the square root of the n, which is the number is 27, subtract by 1. So let's go ahead and do some of this math. Okay, so make this a little bit smaller so that I can see what I'm doing. Okay, I think that'll work. All right, so let's go ahead and do this calculation. So we've got $38,073 subtract 38,000. Oh, that's not what I wanted to do. Got to start the number over again. $38,073 subtract $38,202. That gives us a negative 129. So go ahead and write that down. So negative 129 divide that by 575, which is divided by the square root of 26. All right, that kind of looks a little funny, so I'm gonna write that a little cleaner on the next go round. All right, so let's see here. So Z is equal to negative 129 divided by 575 divided by this calculation. So let's see. Let's see what the square root of 26 is. That is going to be 5, and remember, I'm going out 4 decimal places. So 50990. Okay, 5.0990. Now let me double check that. 5.0990. And the number that follows that that fourth zero, that fourth decimal is a 1, so we don't round up. Okay. All right, so let's do the calculation. Negative 129 divided by, let's see what this number is. Okay, so 575 divided by 5.0990. That gives us 112.7672. 7672. So 112.76, let me make sure, 7672. All right, let's do that last little bit of math. All right, so clear this out. We're going to do negative 129. Actually, the other, this works. I'm going to show you this works. There we go. This works, but divided by, I just wanted to show you that the negative will pop up if you do it that way, which is what I just did, which was to tap the subtract sign. But you could also do this right here, if I remember correctly. I think this should work. Let me clear that out. So let's see. Divided by 112.7672. Oh, nope, it doesn't. Okay, so I was wrong. So when if you don't want to think about it, you just want to plug the numbers in. You know, I intuitively know that when you divide a negative number by a positive number, the outcome is going to be negative. Okay, the only way that this would turn into a positive is if the number in the bottom was a negative as well, but it's not. Okay, so I know, you know, I know that. But if you have trouble with that, go ahead and put the symbol in there. And the way to do that is like what I just did. You click the subtract or the negative sign, 129. It's not going to always show up, okay? But then you divide by the number you want, which is 112.7672. We get negative 1.1439, okay? Because remember, I'm going out 4, so negative 1.1439. Negative 1.1439. And remember, the number after this 9 is a 4. It's not a 5, so we don't round up, okay? But what I want to do is get my z-score down to the second decimal place. So it's going to be z equal negative 1.14. It's followed by a 3, so I don't round up, negative 1.14. All right, what I'm doing here is coming back and looking at the T critical because I need to write that in step 5. So that is negative 1.706. Okay, so our T critical is going to be equal to negative 1.706. And our T obtained is equal to negative 1.14. And intuitively, I can look at this and I know that we're going to reject the null, but let's go ahead and map it out. But before we do, I don't think I said this earlier because I was moving through the problem. And again, you know, I've done these so much that I sometimes forget about steps. Some of you may have, when I said it's negative 1706, 1.706, some of you may have said, well, how did she get the negative? Remember, this is going to be determined by the direction of your test. So this is a one-tailed test. And remember, we said that we're looking at, we said that the question is, or basically the complaint is from the local union of firefighters. The complaint is that they get paid less than the national average, that they're underpaid. So we know that whatever we're trying to find, we're trying to see, do these firefighters in fact get paid less? Are they underpaid? Well, that lets us know that we're looking at the less than sign. So we're looking at everything on this side of the distribution. So everything on this side of the distribution, remember, that has a negative, okay? That has a negative sign. So our T critical is going to be negative, okay? And again, just like the first t-test, just imagine that this curve is a little flatter. I just didn't want to go out and go find a whole new set of curves, but the principle is still the same. The information on this side is going to be negative. The information on this side is going to be positive, okay? All right, so let me clear this out. Okay, all right, so our number is negative 1.706. So I know that's going to be somewhere around here, right? So if you graph it out, if you draw it out, that's going to be around here somewhere. Okay, I just can't draw that for a straight line to save my life. So negative 1.706. Okay, now remember what we've been saying. Everything from this point on, and if it helps you to do this every time. But everything that falls in this color-coded region, this region of yellow, we know that that is going to be our critical region. If it doesn't fall in that region, we reject. And you can just look at this already and you know it's not going to fall in there. So negative 1.14, that's just barely past the 1. Okay, so let's do that. And that's, we're going to write the number up here, negative 1.14. So see, it doesn't fall over there. It falls, it's well short. So what we would do here, when we write this up, this is going to be a little different than the other ones. All of the other ones, you've rejected the null. In this one, you failed to reject the null, okay? The null hypothesis. So with the T critical of negative 1.706 and a T obtained score of negative 1.14, the test statistic, I'm going to say that right one day, does not fall in the critical region. It does not fall in the critical region, which you can see. You can see clearly it doesn't fall in there. Therefore, we fail to reject the null hypothesis. Because remember, the null hypothesis is saying there's no difference between these two groups. Okay, so the difference between local firefighters' average salary and the average salary of firefighters nationwide is not statistically significant. The firefighters' average salary is not significantly lower than firefighters nationwide. There's no differences between them. Okay, that's what that's essentially saying. All right, at this point, I am done. Hopefully, I didn't catch what time it was when I started this, but hopefully this isn't one of those that turned into an hour-long video. We can hope. But if it did, it's still good information. Just, you know the routine, you know how to hit the pause button, which I guess is a moot point because this is the end of the video. As always, if you have questions, you know what to do. Email me, schedule an appointment with me, so on and so forth. But let me know if you have questions, if something still just isn't clicking, and we can set up an appointment to try and see what we can do to get it figured out, or send me your questions and I will answer them. You know, you can put them in the Ask the Instructor discussion board, or you can send your questions to me directly. On that note, have a nice rest of the day, and I will be in touch again soon.